Good evening, everyone. Today we will start conductance, resistance, specific resistance, and specific conductance. Okay. So first of all, let me tell you the symbol of these terms. The symbol of conductance is C. Simple. Symbol of resistance is R. Symbol of specific resistance is rho, and symbol of specific conductance is K. K means kappa. Okay, so let us clearly understand what actually is a conductance, what actually is resistance, then specific resistance. Specific resistance is also known as resistivity. Specific resistance is also known as resistivity. Specific conductance is also known as conductivity. Simple, yes or no? Okay, so what is conductance? So normally conductance means the ease of flow of electrons. Okay, ease of flow of electrons or ease of movement of electrons is known as conductance. Let me take a simple example first for all of you. Let us take a wire. This is a wire. Okay, this is a wire with length. Let its length is 10 meter. Clear? If I pass a current, if I pass a current of 10 ampere through this wire, okay, from A to B, from point A to point B, this is input current, okay, but within the 10 meter of distance, when I normally give 10 ampere of current from A to this, 10 ampere of current will flow from A to B, but there is a what, there is some resistance in the middle part. What is resistance? Okay, from A to, if the distance between A and B decreases, if the distance between A and B decreases, let us take A to B distance is now what, this is the same wire but distance, length of the conductor, this is a conductor, okay, length of conductor here decreases, okay, conductor wire, okay, uh, let 5 meter, okay, so here output current must be more. Are you getting my point? When 10 ampere of current normally flow from A to B, the output current is very low because due to length of conductor. If we compare both A and B, A prime, B prime, then here length is what? Length is less as compared to the first example, 10 meter, here 5 meter. So in 5 meter current flow will more as compared to in 10 meter. That means what? That means here resistance is more, here resistance is less. Both cases resistance is present, but in larger, when the length increases, resistance also increases. Okay, when length become 100 meter, 10 meter to 100 meter, then the output current must be lower. Are you getting my point? Yes or no? That means length increases. When length increases, resistance also increases. That means what? R directly proportional to length of conductor. L means what? L is length of conductor. Very simple. Okay. If I increase the thickness of this, if I increase the thickness of this wire, then what happens? Current flow will increases. Current flow will increase. Why? Because this is called as A means cross sectional area. Cross sectional area means when area increases, the flow of current will be easier. You can easily take the example. If I take a thinner wire, if I take a more thicker wire, then in the thicker wire current flow will more, whereas in thinner wire current flow will be less. Yes or no? That means resistance is inversely proportional to cross sectional area. Okay, resistance is inversely proportional to cross sectional area. When area increases, flow of current will be easier. That means resistance decreases. Yes or no? So by combining both of them, we will get R directly proportional to L by A. Here A is called as area of cross section. Area of cross section. Clear? That means R is equal to rho into L by A. Clear? This rho is called as, this R is called as resistance. This rho is called as specific resistance. Specific resistance or resistivity Clear? L is length of conductor. L is length of conductor. A is cross sectional area. Clear? A is cross sectional area. Clear? Yes or no? Very simple. So R equals to rho into L by A. But this example is actually shows this is a solid conductor. This example is for solid conductor. So we can easily take this relationship for electrolytic solutions. Okay, conductor, different kinds of conductor. This is a metallic conductor, but conductors are mainly divided into two types: this metallic conductor and electronic conductor or electrolytic conductors. Okay, or electrolytes. Okay, so this equation can also be approved by electrolytes or can also be satisfied by electrolytic solutions. So this equation can be satisfied by what? This equation can be satisfied by electrolytic solutions. Clear? This equation can be satisfied by electrolytic solutions. Very simple. Okay, then what about conductance? Resistance clear, resistance is clear. Specific resistance or resistivity is clear. Okay, what is conductance? Okay, reversal means 1 by R is called as conductance, or we can say 1 by C is equal to 1 by C is equal to R. That means reciprocal of conductance is called as resistance. Clear? Reciprocal of resistance can also be called as conductance. Reciprocal of resistance is known as conductance. Reciprocal of resistance is known as conductance. Very simple. Clear? So if I reverse this equation, 1 by C equals to R, that means R equal to 1 by C and rho into L by A. So what happens? C becomes 1 by rho into A by L. So 1 by rho is called as K, and this is A by L. So what is the formula of K? What is the formula of K? K equal to C into L by A. K is called as specific conductance. K is called as specific conductance. C is called as conductance. This is called as cell constant. This is called as cell constant. I hope it is clear to all of you. It's very simple. So mainly in this class we have just covered four types of terms. These terms are conductance, resistance, specific resistance, and specific conductance. Clear? Yes or no? So very simple. It's very simple. So this is all about these four terms: conductance, resistance, resistivity or conductivity, or this is called as what? Specific conductance. Clear? So that's all for today. Thank you everyone.